So use this video now that you've done the homework and taken a quiz to go back and review your homework and take a look at what little areas you might need a little work on. This one's mostly just, this first question is proving to someone what a chord, an arc, and a central angle are. So what you want to do is kind of helps to make a few things here. And you can do this any way you wanted, but I'm going to look at some points here and I'm going to put labels on it. And you can probably make any kind of defining. You might define an arc as it goes around the circle. You might define it as it's an angle measurement, so it's in degrees. What other way would you define an arc? There's a lot of different ways to define what those are, and then you might want to say, okay, well, I'm in blue here, so I'm going to make a blue arc. There's an arc right there. That's an arc. And I might just go, that's an arc right there. So I kind of know what one is. You make them over here with another color and say, well, let's see, now I'm going to take a look at a central angle. I'm going to make one right there. And I'm going to say a central angle. You know, so I'm just making notes. I'm just saying to myself, look at that. The vertex is in the center. That's the big deal about a central angle. That's probably the biggest thing. So I can say the central angle is right there. So that hopefully would tell somebody, well, I know what that means. If I'm asking about a chord, let's go to green. Chord, what's a chord? I'd probably go right over here and say that's a chord. I'd probably go right here and say the diameter is also the chord. And so I'd go down here and say, chord. Intersects at 2 points on the circle. A diameter is a yes, because a diameter can be a chord. And it's also a straight line. Straight line. So just whatever you do there, there's a lot of things you could probably do for that too. Now that's just basically notes and an original drawing. That's what we're looking for there. Then we come over and we look at this inscribed angle. So this question, these came right out of the book actually. For figure 1, so you're looking at figure 1 and you're estimating. So for figure 1, that's our big deal right there. We are estimating. So estimating means just guess. That angle right there, that central angle right here, looks to be about approximately, you could just say 20 degrees. That's fine. You could say 30 degrees. You could say 28 degrees. It doesn't matter. Because the main idea when you estimate that, CAQ is 20 degrees. And then CBQ, that is the inscribed angle. That is what all you're really doing in this exercise is comparing the fact, you got to know if that's half. That's what that is. That's the inscribed angle theorem. Go back and look at your lesson summary if you need to, on lesson, I think 2 on that one. All right, so what's always true about those angles? It's the same thing's true over here. This angle right here, the central angle, is equal to the arc, which is all equal to 1/2 that inscribed angle. So whatever this is up here, central angle arc, the inscribed angle is half. So the inscribed angle is half of the central angle. That is the theorem. And we're just using it there, just kind of playing around with that. All right, then knowing that, we come into a little bit of work from questions from lesson 3. You got to first look at this arc here. If this arc or diameter is 180 degrees, that's a 180 degree angle and a 180 degree arc, then that means that this guy over here is 90. That's inscribed. But that actually is just one piece of the problem. The other piece is that over here we've got a situation where this angle is 116, this arc is 116. Well, if it's going through a diameter, so it's got to be, the difference is 180 minus 116. So that's what's left over here in arc RS. So 180 minus 116, if you have to have a calculator for it, you get 64. So that arc is 64. That means the angle inside, on the inside here, is 32. So let's see if I can answer any of these questions yet. Arc RS measures 64 degrees. How do I know that? It's 180 minus 116. It's part of a semicircle, which is 180 degrees. Angle RTS is 32 degrees. How do I know that? it's half of its, we've been using this word a lot, associated arc. Half of the arc. Now, as far as the solving piece goes, solving now, that 17x minus 2, that's the angle right there. So 17x, oops, pen, not lines. 17x minus 2 equals 32. Because the angle is 32 degrees, and you're just solving for x. So 17x equals 34, x equals 2. There's my solution, there's my calculation. So the algebra in there is just a little bit of solving practice, not much. Let me come over to the tangent idea. This is from lesson 3. So if there's a tangent, the tangent angle is always 90 degrees. So angle B is always going to be 90 degrees. Always. Because they said that is a tangent. BC is tangent to the circle. So if that's 90 degrees right there, a little square angle, that means it's a triangle. They add up to 180. So the other two angles, A plus C, has to add up to 90. They're complementary, right? That's what they're saying there. So what's the value of A plus C? Value. I think a lot of people gave me a much bigger answer than this, but just what's the value? A plus C is 90 degrees. What's the reasoning? Well, I've shown my reasoning. It's because one angle, this one's 90, therefore the other two have to add up to the other 90. That's because 90 plus 90 is 180. So there's a lot of ways to show that mathematically. But in the three angles of a triangle, all triangles always add up to 180. So a lot of different ways to say that, but really looking for this kind of idea right here, that the two angles are complementary. They add up to 90 degrees. Missing side lengths. Oh, let's see. A lot of this is Pythagorean theorem based, so we're going to use that. Some of it's trig based. Let's take a look at what we got here. This side length right here is 1.5 plus 1, so it is 2.5. This side length over here is 1.5 because it is a radius. So we're just looking for the third side length, and we know that that's a right angle. So you kind of have to know that these are right angles on all these, that those are right angles, right angles, right angles. Tangents are always right angles. And at that point, you're using Pythagorean theorem to solve them. Okay, so we're just using Pythagorean here. We're just using the square root of, that's a hypotenuse and a leg, so it's going to be 2.5 squared minus 1.5 squared. And if you do that, you'll get an answer of 2 for that side length. Over here, you got 12 and 16. Now, if you recognize this is for what it really truly is, it's a Pythagorean triple. If you recognize that, this becomes an easy problem. That's 3 times 4. This is 4 times 4. That should be 5 times 4. It should be 20. That's if you really know your stuff. If you know Pythagorean, if not, use the Pythagorean theorem. The square root of 12 squared plus 16 squared. You'll get there. You'll still get 20. All right. So either way, and then I come over with the next figure, and it's like, it's got the same thing going on here, except I don't know the little small piece side. It's just the same figure, really, as the one before it, 12, 16, same circle. So that means that long side has to be 20. I've already made that calculation. But the radius is 12 right there. So that means 20 minus 12 has to be 8. So that's where that's coming from. All right. Let's take another look here. Going on down the line. Now when you come down to these further ones, the key things to note here. Those are right angles because they're tangent. So you assume the lines that are tangent are tangent. Those are right triangles. Now, well, it's a right quadrilateral, but if you make a little line down the middle, you'll notice they are two right triangles with the same radius. That radius doesn't change. So that's 4.8. And so they're equivalent. They're basically equal. So all you're doing is setting 2x minus 14 equal to x minus 2 and solving. That's all you're doing. 2x minus 14. That's equal to, those side lengths are equal. So you're just setting them equal and solving. So it's really just once you know the geometry, the algebra is pretty easy. So 2x minus x is x. Minus 2 plus 14 is 12. You're good. Same thing over here. You got the same situation almost, except that you could write in the radius here of 18.4. So you got to recognize some of the geometry ideas, that you got right triangles, that you got equal radiuses, radii, and then you're just doing the same thing. 11x plus 2 equals 12x. And you might actually say that, well, 12 times 2 is 24, 11 times 2 is 21, or excuse me, 22, plus 2, so x equals 2 here. Or you can solve it either way, but you're solving those. Okay, let's keep on moving right here. Last one, we got a circle, name 2 chords, any ones you want. Actually, there's only 2, and they are diameters in this case. EB and CF. Name 2 center angles. Well, you got a lot of them. You got a ton of them. You can name them. And then it gets into the angle measurements. DPE. DPE. I'm going to mark that one off. DPE. The circle's P, by the way. Or the center's P. So this angle right here is what I'm looking for. That one right there. So what do I know? Well, if I've got 126 here, and then if I notice that it actually is a diameter. BE is a diameter going across, and that's just 180 minus 126. So that's 54. So that's what this one is right here. 54, that's a 54-degree angle right there. If that's a 54-degree angle, BC over here is also a 54-degree angle because those 2 diameters make up not parallel lines, but they cross. So they make up vertical angles. So those are vertical angles right there. And then you keep going. That means that also this other angle over here is 126. So if I go around this arc around the side here, that also has to be 126 because that's a vertical angle to the other 126. And then they say that those angles in between are equal. There's a little mark right there. Let me erase so I can see it right there. They actually are given that those are equal. So just divide that by 2. 126 divided by 2. That gives you this 63 and another 63. Now I have all the angles. DPE, where is it? DPE is 63. Arc BCD. BCD, that's going to be on the left side. That's 54 plus 63. That's because, that's 117. That's because you add them together. The central angles are equal to the arcs. So that is what did I say, 117? Yeah, 117. Okay. Is angle CPE vertical? Let's erase and check. Let's go back. So we're looking at CPE. CPE, that's this one. And is that vertical to BPF? Yes, it is. They're vertical angles because they're made up of, so that is a yes. How do you know that? They're made up of 2 diameters. Just go right through the center. All right, so we'll stop it right there. Let's check that one out. We'll upload it here in a little bit. And done.